preserve history to help remind us of the past events that formed the society we live in today. To understand the present we live in, we look to our past to see the foundation we were built on. Through keeping relics from the past, we can remember what sacrifices were made to achieve where we are now. It helps us to remember how the past has proven to be great, or perhaps how we shouldn't repeat it. It also helps us appreciate those who made it possible. Preservation is important because it is what helps remind us of the past and helps keep it relevant to us. When an object associated with history is gone, there is no way of truly bringing it back. If we let the tethers to the past disappear, then we'll forget what brought us to where we are or what to try and avoid in future. Much like memorials, they help us remember the past and look towards the future. By preserving and learning of a place's origin and how it was used, it helps make it relevant to the present and makes us understand why we need to keep this piece of the old world with us. Through the use of digital models, scanned objects can survive decades or even centuries after an object has succumbed to time. The light detection and ranging, otherwise known as the LiDAR, is a scanner that fires lasers out at a frequency that scans objects. It's safe for eyes, so it does not yield any sort of hazards. Objects scanned with the LiDAR can points of data in a 3D viewer. When objects are scanned, it is to the millimeter, but with more time and care, it can go to even smaller unit levels that are not visible to the naked human eye. The LiDAR is an amazing piece of technology. A century ago, nobody would have thought of using a machine to digitally encapsulate an object. Now that the world is equipped with this means of preservation, we can continue admiring, examining, researching, or perhaps restoring these relics. Unfortunately, even with human preservation efforts, some objects in history decay with time. Historians, however, can scan nearly perfect replicas of these objects. With the digital replicas and the constant advancement of technology, it is an accurate and easy method of preservation. Currently in Mid-Pac's 3D scanning class, we've scanned a historical building in Fort Shafter, and we have also skilled an old Douglas dive bomber which has flown and seen the combat in World War II. Other professional companies like SciArc have worked in preserving whole ships and buildings. Recently, SciArc scanned all the interior of the battleship the USS Missouri. In these videos, my class works on scanning different sections of Building 118 in Fort Shafter. The buildings in Fort Shafter have not been changed or rebuilt since their origin, so it is in our best efforts to make clean, viewable 3D models to add into our digital archive to view in the future. The process of making a 3D model, however, is no simple feat. It takes time and effort to make viewable, movable, pristine models. The first step would actually be to scan the desired object. In this case, my class scans a historical building in Fort Shafter. A single scan cannot capture the complete and whole essence of the building, so we conduct multiple scans around the building to have a full model. In a sense, the scans are like small drawings that will eventually lead to a big drawing. A single scan is a small drawing. To make a big and complete drawing, we need plenty of small drawings to fill in the full picture. The scans, however, must overlap at least 15% to be considered a good scan. The overlapping will help put the drawings together better to create a better and more whole picture. The second step after scanning is registering the scans. By using the program Scene, we can register a scan in its raw scan file and convert it into a file format that can later be manipulated in another program. The format is to construct the big picture. The raw scans will be converted into a PTX file. The PTX file is compatible with the program Cyclone, which will be the next step. The third and most important step is using the program Cyclone. After importing the new PTX files from Scene, it can be viewable as a 3D model in Cyclone. This is the part where we sew all the little pictures together to form the big picture. The different scans will be connected to one another using this program. You will notice phantoms in your scans. These phantoms are random data points that are simply random particles in the air, or sometimes people who pass through the scans. Since all the particles are scanned by the LiDAR, this happens frequently. Don't worry about these points though. They will be cleaned up later for a more completed and complete look. We can sew together two scans that overlap each other by selecting points that are shared between the two scans. The overlapping scans will need at least 6 shared points between the two. 6 is a strong number of points as it will make the scans tight but still flexible to the other scans that are yet to be added. Keep in mind to only add points to objects that don't move, like the ground, a wall, or maybe a pole. Try to avoid trees because the points do move enough that it will give you an error. Also, never add a point to phantom data or black holes of data. Phantom data is never intended to be scanned, and as such should not be used to add points. Black holes are literally places where there is no data, so it is unwise to select a place that contains no data. There are no points to be selected. Remember, the scans are not put together at random. It is in a given order so the right pieces go into the right places. In a puzzle, you don't connect the upper right corner piece to the lower left corner piece. Doing so will make an unclear image just as it will in scans. After all the scans are combined together in the correct order with minuscule margin of error, then your overall scan is nearly ready to be exported as a 3D model. When the full scan is viewed as a 3D model, it should look like what you want it to look like. If there are anomalies like random walls or objects that don't belong, then the points need to be reselected. This is the final step, Bentley Point Tools. The purpose of this program is to clean up all the phantoms and stray data points. Import the previously completed scan file from Cyclone. Now you're going to clean up all the phantoms. This is a time-consuming process as you must be careful not to erase the actual good parts of the scan. After everything is erased and your scan looks pristine and like the object you initially scanned, then you are done. My class has already completed all of this. At the rate we're learning and gaining scan experience, we hope to be able to professionally scan and digitally store the relics that need to be saved. We cannot afford to sever the nexus that connects us to the past. In a sense, the LiDAR scanning is acting as time's conflux, a merging point of old, modern, and even new history. We preserve our past to remember and learn for the sake of our future.
And that one is you, no other will do. I've lost all ambition for worldly acclaim.